are discussing about scheduling of sequential activities. That is, the problem of minimum path finds an important application in scheduling and coordinating various activities in a project so as to complete it in minimum time at a given cost. Also, it is possible to estimate the least rise in cost or the maximum saving possible if certain activities are speeded up or slowed down to finish the project within a prescribed period. Okay, a project involves a number of activities or operations or jobs which we identify as vertices VA etc., VJ etc., some VK etc., and VB of a graph. VA represents the beginning and VB the end of the project. Each job VJ requires some time for its completion. It may not possible to start on a job unless some specified time has been spent on some other job or jobs. Okay, the problem is to find the minimum time in which the project can be finished and the time scheduled for each job. Let CGK be the time required on job VJ before job VK can start. It is the time interval between the start of the two jobs, VJ preceding VK. We indicate this information by drawing the arc VJ, VK and associating the length CJK with it. The time required to complete VJ is represented by arc VJ, VB of length CJB, as it would mean that the time CJB should be spent on VJ before the end VB can be reached. Also, if VJ can start only after some time has passed from the beginning of the project, we may indicate it by CAJ. So, all arcs VJ, VK with the length CJK will in this way denote a sequential relationship in terms of time among various jobs. Okay, each sequence of jobs which must be done before work on VJ can begin as represented by a path connecting VA to VJ. The longest of these paths determine the earliest time VJ can start. Okay, so in this way, the longest path joining VA to VB gives the minimum time of completion of the project. The problem thus reduces to finding the maximum path with arc length CJK or the minimum path with arc length of minus CJK. So, this path is called the critical path.